Hello and welcome to the video series on runtime analysis for AUTOSAR embedded projects. My name is Florian Sommer and I'm responsible for the business development of the product line embedded software at Vector Informatik in Stuttgart. In this video, I'm going to explain to you how you can automatize the toolchain for real-time analysis. Let's first of all have a look at the overall toolchain and all the steps you need to do in order to get a scheduling trace and analyze it. First of all, we have 4 steps in this process. The first step needs to be done in the basic software that you are using. So if you're working with Microsar, you will need to configure the OS hooks in the DaVinci configurator in order to be aware of the state transitions of the different tasks. And if you want to additionally record also the runnables that are running inside the tasks, you can additionally instrument in the DaVinci configurator the virtual function bus hooks. With that, you will also get the OS awareness file that can be used in order to configure your debugger so that it can record the scheduling trace. Once you have also finalized the configuration of your trace debugger, you will need to download your software to your ECU and start the trace measurement. After the trace measurement, you will get the trace data in different formats. That depends on the trace vendor you're utilizing in your project. And this trace format can then be imported into the Timing Architects tool suite, to be more precise, into the option TA inspection. And this will allow you to analyze the trace against different requirements, to have a look at the Gantt chart that I have shown in previous videos, and do different types of analysis. Additionally, if you want to evaluate against requirements, you can also have requirements input. So you are defining your requirements like task deadlines, event chains, a maximum allowance of CPU load, for example, in the early phases of your project, and you can later evaluate this kind of requirements against the recorded scheduling trace. Based on these requirements and information that you put into the TA inspection, you will be able to automatically generate timing reports. These timing reports are completely customizable, so you can cover inside these reports, for example, different requirements. You can also cover the CPU utilization and so on. So that are the 4 different steps that you need to take in order to get such kind of analysis. So how can all of this be automatized? In the Timing Architects tool suite, you will find a part where you can create so-called workflows. And these workflows have different job nodes. So every of these green boxes that you see here contains interaction with the GUI of this tooling that you can either do manually or you can automatize it by using these workflows. And what this workflow here does, as an example, is it's first of all loading the DPA file, so the configuration that you have in your DaVinci configurator project. And as a next step, of course, we know where the necessary ARXML files are. So this is the ECUC and system description that's generated by the DaVinci configurator. And we then do, with the next job node, a import of this system description and ECUC in order to create a timing model in the Timing Architects tool suite. This step here, the first 2 job nodes, are specific to DaVinci configurator projects. In case you're working with other AUTOSAR stacks, these will also provide you with a ECUC and system description, so you can simply load directly the ECUC and system description instead of linking the job node to a DPA project. In the next step, you will now need to set up your trace debugger. And once this trace file is available, you can automatically load this trace file and combine it with the timing model as well as the requirements that you have defined earlier on, and do an evaluation based on this input. And this evaluation report is then saved. So you have then a HTML report where you will see whether your requirements are fulfilled, how is your CPU utilization, and you can distribute this internally for project management purposes, or you can also generate different reports. If you say, okay, I want to have one very detailed report for internal reporting, and I want to have a general report that provides an overview to my customer about CPU utilization, for example, you can also do different reports that you distribute afterwards to different sources. And if everything is green in these reports, everything is fine, you will not need to do any additional analysis. If you find some requirements that are violated and you would like to investigate in more detail, then you can also always go ahead and go back into the tooling and use this evaluation that has been created here within these job notes and dig into the details, do an interference analysis, and come up with different ideas on how to solve the problem. At the end of this video, I want to offer you some possibilities to stay in touch and find out more about timing analysis. For that, I'm inviting you to join the LinkedIn group Runtime Analysis in AUTOSAR Projects. In this group, you will meet other people working in this field, sharing their experiences and solutions for this topic. And you will, of course, also be able to engage in discussions and ask your questions there. Just search for the group directly on LinkedIn, or if you want to have it easier, I put a QR code here in the video so you can simply scan the QR code and you will be redirected to this group. Would be happy to have you in the group. If you have questions to me directly, or if you want to connect with me, I'm inviting you to scan the QR code here on the right. You can also see the link to my profile here on LinkedIn. I would be very happy to connect with you and answer any questions you have. Thank you very much for watching this video. I'm looking forward to stay in touch with you.